Lesson 8.4, classifying triangles. Here's the deal. All this is you have to be able to tell me what type of triangle is staring at you in the face. Okay? Here's the deal. A triangle is a three-sided polygon, a three-sided closed figure. Okay? Triangle. Right? Triangle. Triangle, right? Here's the deal. There are two different ways to classify triangles, two different ways to identify triangles. One is to identify triangles based on their angles. Okay? If I have a triangle that looks like this, you'll notice that, first of all, triangles have how many angles inside of them? Three. There's always three. Did you also know that triangles, the internal angles, the angles of triangles always, I don't care what size the triangle is, that the internal angles of triangles always add up to 180 degrees. That's just the rule. The angles inside of a triangle add up to 180. Okay? So, knowing that they add up to 180, here's the deal. What type of angle is that? What type? That's an obtuse angle. What type is this? Acute. What about this one? Acute. I have two acute angles and one obtuse angle. If there is an obtuse angle in a triangle, then that triangle is called an obtuse triangle. Here's the deal, listen. Can a triangle have more than one obtuse angle in it? Can a triangle have more than one obtuse? How big is an obtuse angle? Bigger than 90. If the angles inside of a triangle always add up to exactly 180, you can't have two angles that are more than 90 inside of a triangle. Does that make sense? It's not possible. So, if there's one obtuse angle inside of a triangle, it's called an obtuse triangle. If there is a right angle in a triangle, that means it's called a right triangle. Right? And the only other option for triangles would be what? If there were all three angles were acute, if that was smaller than 90, that was smaller than 90, that's smaller than 90, if they're all acute angles, then that triangle is called acute. Does that make sense? Obtuse triangles have an obtuse angle. Acute triangle means that it's all acute angles. A right triangle means that one of the angles is a right angle, which is a 90-degree angle. How do you know if a triangle is a right triangle? You'll look and see they'll put that little box there to tell you that one of the angles is a right angle. Make sense? Okay. All right. There's the other way of determining of classifying triangles is to base it on its sides. Okay? To base it on its sides. If a triangle has sides that are all three different lengths, if all three lengths are different, then that is called an isosceles. That's not how you spell isosceles. Isosceles triangle. Here's the deal. One way for them to tell you that the sides are different would be to go like this. And you need to pay attention to this because I ask you to write for me isosceles as part of your project, right? Is you go like this. You put a single dash through that one, 2 through here, and 3 through here. That lets us know that they have, all three of them are different sides. Does that make sense? Another type of triangle is if two of the sides are exactly the same. How would I let somebody know without putting an actual number? Like if I go 6, 6, 3, you know that these two sides are the same because I've told you. But even if I didn't put numbers there, how could I let you know that those two sides were identical? What could I do? Yeah, one single dash here, and two here, meaning that these two are the same, but this one is different. Does that make sense?
Yes.
This is called what's it called? I'm wrong. This is not isosceles. What am I talking about? That's scalene. Goodness gracious. Yeah, this is scalene. I'm out of control here. Sorry. This is scalene. No sides are the same. Isosceles. Isosceles means that two of these sides are the same. One is different. That's isosceles. And the other type is when all three sides are the same. How would I draw that? How would I let somebody know that all three sides were the same? Or what about this? Could I do that? Yep. Yeah, it doesn't matter. You're just letting people know that all the sides are the same. And this is called an equilateral triangle. Equal. Wow, I'm spelling horrible today. Equilateral. Does that make sense? Yeah. So listen, every single triangle is technically two different triangles. If I go like this. How would you identify that triangle? That is a scalene triangle. Why is it scalene? All three sides are different. What else is it? It's a right triangle. It's a scalene right triangle. Scalene right triangle. Because based on its sides, it's scalene. Based on its angles, it's a right triangle. Okay. What about this? That's an isosceles. Acute. All those angles are less than 90. These are less than 90 barely. This one's way less than 90. That's an acute isosceles triangle. What about this? That's an obtuse isosceles triangle. Isosceles because it has two sides that are the same. It's obtuse because it has an obtuse angle. Does that make sense? Does that make sense? Okay, really, that's it. The only other thing you may have to do here is this. What if I do this for you? I tell you that, what if I go like this? And I tell you that this is 85 degrees, and this is 60 degrees. Can you tell me what x is? How? First of all, can you? Do you have the ability to tell me what x is? Yeah. How do you know? What can you do? What is true about the angles inside of a triangle? What is true? They always add up to 180 degrees. The sum of the internal angles of triangles is 180 degrees. So, 85 plus 60 is 145. We know that it has to add up to 180. That means that x is 35 degrees. Does that make sense? Does that make sense? I think you guys can do this. Any other questions about this? What if I did this for you? What if I just told you that there was a triangle that it had sides that were 4, 3, and 6? What do you know about this? You know that it is scalene. I didn't even draw the triangle. I just told you that the sides were 4, 3, and 6. That means you know it's scalene. What if I said the sides were 5, 5, and 5? Equilateral. What if I said it was 2, 2, and 4? Isosceles. You're just thinking, right? You're just thinking. What if I told you that all the angles inside of a triangle, the angles were 75, 75, and 30? What do you know about this? Tell me what you know about this triangle. It's an acute triangle because all the angles are acute. You also know it's isosceles because you're going to have two angles. But with that, that's for like next year. But either way, you know it's an acute. What about this? What if I have one that is 101 degrees, 80, well, it can't be 80, 101 degrees, 10 degrees, and 69 degrees. This is an obtuse triangle. How do you know? Because there's one obtuse angle. I think you guys have this down. I think you're in good shape. Let me give you your homework. Aren't you excited when I'm in a hurry, then good things happen for you. Page 382 to 383, 5 through 20 even, and 28 to 32 even.